Today we're going to practice finding the surface area and volume of a rectangular prism. Notice in this problem in front of me there's no picture. Sometimes on the EOG they'll give you a word problem like this and expect you to draw the picture. As I read through the problem with you, I'm going to highlight the important information. Sandra is covering a rectangular box with decorative paper. If the box has a length of 15 inches, a width of 9 inches, and a height of 4 inches, how many square inches of paper will Sandra need? The first thing you ask yourself is, what shape is this? It's a rectangular box, which means it's a rectangular prism. So on your paper, it's a good idea to draw a rectangular prism. It doesn't have to be perfect as long as you've drawn it. Now they tell you the length is 15, the width is 9, and the height is 4. It truly doesn't matter which values the length, width, and height, as long as you have all of them there. It's easiest to match it up according to the numbers. So 4 is my smallest. On my picture, this is 4 because that's my smallest value. I'm going to make this value 9 and this value 15. Don't forget to include your units. So now I've found my 3 different values. The last thing you have to ask yourself is, what is it asking for? This problem is asking for how many square inches of paper will Sandra need. If you think about this problem, Sandra is covering this with wrapping paper. When you think about covering an object with wrapping paper, it's like the cereal box project when we covered our cereal boxes with grid paper. This problem is asking for surface area, so I know that I'm going to be solving for surface area. Later in this video, we'll practice solving for volume just so you see it. Remember that with surface area, we learned how to make a chart, and the chart has us break it down into the different rectangles. The first rectangle is the front and back, which we abbreviated as F/B. The next one is the top and bottom, and the last one is the left and right. Inside of each of these charts that we created when we did surface area, we always wrote the formula of the shape. That's just good practice because next year and later on in math you're going to learn how to find the surface area of triangular prisms and other shapes, and it's always helpful to write the formula inside your chart so you remember what shape you're finding the area of. Remember that surface area is covering the shape. We are going to highlight each of the different pieces with a different color, so I'm going to highlight the front in green. I'm also going to highlight that on my chart in green, so I remember the front is my green rectangle. The top is going to be in pink, so I'm going to highlight my top rectangle in pink, and I'm going to highlight my left rectangle in blue. If the front, back, top, bottom, and left, right confuses you, you can always think of it as green, pink, and blue. It's just the 3 different rectangle pairs. You know that if there is one green rectangle in the front, there's another green rectangle in the back. So when we find each of the areas, we're always going to multiply it times 2 because there are 2 areas, or there are 2 squares or rectangles. It does not matter whether you multiply by 2 every single time or if you wait until the very end and multiply by 2. You get the same answer. If I look at my green rectangle in the front, the dimensions are 4 and 9. So the area of a rectangle is length times width, so I'm going to come up here to my chart and I'm going to do 4 times 9. 4 times 9 is 36. There's 2 of those rectangles, so when I multiply it by 2, I get my the front and back boxes to be 72 inches squared. I'm going to leave my units off to the very end, although you can fill them in throughout. The next one is the top and bottom. That one's a little bit harder to see. If I look at my pink rectangle, I need to figure out what this front value is and what this long value is. Now, there's no numbers written there, but I can look down because rectangles have parallel sides. This front value I can see as 9, and this up and down value I can see as 15. So my dimensions are 9 times 15. When you multiply 9 times 15, you get 135. There's 2 of those, so when I multiply that by 2, it's 270. The last one is the left and right. I can see that this long piece is 15. The short piece I don't know, but since rectangles have parallel sides, I can look over here. This short piece is 4, which means that this short piece is 4. So these dimensions are 4 times 15. 4 times 15 is 60. So times 2 is 120. The total surface area is these three values added together. So if I add these three values together, I get 462 inches squared, which is answer choice B. Some of you guys learned a formula. Underneath this, I'm going to write the formula for surface area. You're welcome to use this formula on the EOG if you prefer that to the chart method, but please keep in mind the EOG does not necessarily provide formulas, so you're going to have to memorize this formula. The formula for surface area of a rectangular prism is 2 times length times width plus 2 times length times height plus 2 times width times height. You multiply each pair of numbers times 2, add the three values together. It is the same thing as the chart. Now this problem didn't ask us for volume, but we're going to review volume anyway. Please remember that the volume of any prism is the area of the base times the height. So if we think of the base of this rectangular prism as this green rectangle right here, we're going to find the area of the green rectangle, which is 4 times 9. We're going to multiply it by the height of the prism, and the height of the prism is always the value going back, so the height of this prism is 15. The formula is length times width times height. If you think about the length being 4, the width being 9, and the height being 15, you're really just multiplying those three values together, which is the shortcut that most of you will remember. So you come down here, fill in your length, width, and height, 4 times 9 times 15, multiply those values together. You get 540, and it's inches cubed because you're multiplying by 3 different dimensions. Each of these should have had an inches written all along. Miss Phelps didn't do that. She is sorry. You multiply by those 3 inches, it's inches cubed, and it's 540.